Hi, I hope it's recording. I'm going to try and do 3 demonstrations to do with diffusion experiments. So the first one, if I get a beaker, I put some water inside the beaker. Water there. Now, I want you to picture in your mind's eye that the particles inside the water are moving about. Now, excuse the cloudiness that came out the tap, but the particles are indeed moving about, but we can't see the fact that they're moving about. So we need something coloured to try and point out to us that there is some movement going on. And what we're going to use is a few crystals, a few grains of potassium manganate 7. So potassium manganate 7 is very purple, highly coloured purple. If I just try and drop this in the middle and hope that it goes down to the bottom, I'm hoping you can see there. Let's move it a bit. I'm hoping you can see there that the purple colour has largely concentrated into the bottom of the beaker, and towards the top end of the beaker here is relatively colourless. And if the particles of water were not moving, then the colour, the purple colour, would stay where it is now and the colour would not spread out. Now, because the particles here are moving, I am expecting the colour to spread out. As the water particles move around, they will knock the purple potassium manganate particles around. As the manganate particles get knocked around, the purple colour will spread to new positions. And because the particles in a liquid move slowly, then this spreading out will happen slowly. I'm going to leave it now. Typically when I do it in class, I leave it for about a week and I come back after about a week and have a look at it and find that the colours spread out everywhere evenly because the particles are moving about in all directions randomly, and they will carry the purple particles from place to place and the colour will spread out. So we'll just put that to one side and show you this other demonstration. Now, this is the famous long tube demonstration where we need a bit of cotton wool in this end, a bit of cotton wool in this other end, and we put hydrochloric acid concentrated on one end, concentrated ammonia on the other end, and I'm going to dip these cotton wool plugs into these chemicals so that the ammonia, concentrated ammonia here, concentrated ammonia will, if I put it in this side, it will give off ammonia gas. Similarly, concentrated hydrochloric acid here in this hand, when I put it in this end, it's going to give off hydrogen chloride gas. Now, if I try and get this level, like that, get the 2 chemicals, put them in, I'll explain what happens. But the key to this is to put them in at the same time, because we want to see the spreading out, the diffusion happening, and link it to rate. So there, I put both plugs in at the same time. And what's going to happen now is the ammonia will diffuse that way. The hydrogen chloride gas will diffuse that way. And where the two gases meet, there will be like a white mist of ammonium chloride. Ammonia gas and hydrogen chloride gas react to make ammonium chloride. Watch, I show you. There's ammonia gas coming off from that bottle. There's hydrogen chloride gas coming off that bottle. And if I put the two together, I don't know if you can see it, but you should see some mistiness there. You see the mistiness? Perhaps if I come close to the camera. Perhaps you see it on my dark skin. The mistiness is where the two gases meet and the two gases make ammonium chloride. Now, the good thing is that the mistiness here will appear. It's appearing here. See where my finger is? I don't know if you can see it on the video, but it appears closer the hydrogen chloride end. So in the same time, the ammonia has travelled this distance and the hydrogen chloride has travelled this distance. Now, 24 litres of this gas, ammonia, 24 litres weigh 17 grams. 24 litres of this weigh 36.5 grams. So the density of this is more, the density of ammonia is less, and that's why the ammonia, being a lighter gas, will diffuse and spread out faster than the hydrogen chloride gas, which will diffuse and spread out slower. So at the same time, you get the mistiness, the white ammonium chloride appearing here, and it's not in the middle because lighter gases diffuse faster than heavier gases. So that's the second demonstration. Let's put that to one side. The final demonstration is something I've got to be careful about in terms of safety. So I've got here a gas jar and another gas jar. You just check the two gas jars do fit over each other. Now, to show you diffusion in gases, ideally we want to have a gas that is coloured so we can see it spreading out. Now, there aren't many gases open to us that are coloured. I mean, chlorine is coloured, but it's not coloured enough. What we actually use is this nasty stuff here, bromine. Bromine is a red liquid, and what I'm going to do is to take a drop and put it in here. Now, bromine is a red liquid, but it's very volatile, so it will turn into a brown gas. Put a drop in there, it will turn into a brown gas. We should be able to visually see the brownness. Then, if I put this air gas jar over the top, I'm hoping we can see the brown gas spreading from the bottom jar to the top jar. Even though bromine is a much, much heavier, more dense gas than the air. Now, the problem is, how do I get the drops into there? I need a fume cupboard, and I've got a fume cupboard over there. I'm just going to put a drop of that into there, put the lid on. I'm going to do that inside the fume cupboard, and I'm going to come back. Just give me a few seconds. Right, I'm over to the fume cupboard. I am putting a few drops in, turn the fume cupboard on. Now, back. So you can see here, I put a couple of drops of bromine liquid in there, and you can see that it's turning into gas as we speak, because it's a very volatile. Volatile means it turns into a gas easily, and it's doing that now. And if I get some white paper to show you the colour perhaps. White paper. I hope you can see maybe that colour there like that. So the brown gas, that is bromine gas, the top gas jar, this is the empty side, I'm going to put it upside down over that one. I'm going to pull out the cover slip, and there we've got the two gases. Maybe if I change the camera angle a bit, you can see here I've got bromine here as a brown gas. I've got air in this as a colourless mixture, and what will happen is that the random movement of these particles will be such that the brown particles will knock against the air particles, and the randomness of the motion will mean that some of the browny colour ends up in the air above. Even though 24 litres of bromine gas, 24 litres of bromine gas would weigh 160 grams, and about 24 litres of air would weigh about 30 grams. Bromine is much more dense, much more dense. By normal logic, people would say, well, bromine should stay at the bottom being very dense. Well, because of diffusion, because of the particles are moving, then I do expect the brown colour to spread above because of the random movement. Even though the particles are heavy, some of them will knock against the air particles and end up in the gas jar that's above. So 3 demonstrations. This one, we should see the spreading within the lesson. In fact, you can probably see the spreading from the bottom up towards the top end of the gas jar while I've been talking to you. And if you keep watching it, it will end up as an evenly spread mixture eventually. Might take a few periods, but it'll end up evenly eventually. And if I look at the first demonstration I did, this one, then you can see the purple colour is more at the bottom, very faint at the top. And you're going to have to trust me that if I was to leave that a week, then it would look like this. It would look, after a week, it would look like that, because all the purple particles would have spread out throughout the beaker. The particles of a liquid spread out slower. The particles of a gas spread out faster. And light gases, low density gases, they diffuse faster than heavier, higher density gases. So 3 demonstrations. I hope that recorded well. I'm going to stop it